In the name of God, the most gracious, the most merciful.
In these 5 minutes, we will try to see how we can deduce the pile capacity that I can handle in the design below caps or rafts. Always in all the geotechnical reports that we receive, there is an indication in certain way or another that shows me how I can know the pile capacity, so that I can estimate the number of piles under each column and pile cap or below the raft. So now, the shown table here has been received from one of the geotechnical labs and tabulates the pile capacity breakdown. In the session, I will explain how it works and also to be as a reference for any similar received from any other lab in different way. Basically, the table tells that we have at upper left, as we see, the pile diameter of 1.2, for example, in this page. It gives you more than the pile diameter in each page. It gives you if it is 1.00, 1.50 m, and so forth. Sure, this will be in more than one page. Each page has the same table format, but with different values, of course. It also gives me the FCO, which is the axial capacity of the pile, which means that the flexure component is not considered, so we take the load as axial resistance only. Accordingly, we have to reduce its capacity. For example, if FCO is 25, so we take 0.25 times 350 kilograms per square centimeter. This gives FCO equals about 90 kilograms per square centimeter, where FCO is cylinder compressive strength. The important thing is that its FCO is about 0.25 of the FCO of the compressive cylinder strength. FCO as a column. And of course, we do not take the reinforcement component with us. By the way, we only take the axial load component. Now, let us check column on the left in this table, which indicates the depth of the pile. The pile, as you know, extends from the face of the natural ground level as much as you want deeper in the soil strata. So, of course, here this table tells me to take care of its resistance in the friction, which is 0. Up to a depth up to 6 meters, I have the load not working because the soil is very loose and very weak. You can even write it below the table. You will find it written in one of the notes. First 6 meters were neglected from the calculation. According to basement, it is not considered at all. Even the soil is strong. Therefore, either the soil is very weak, the basement will be there. So there is no skin friction component. Okay, up to 6 meters. As soon as it passed 6 meters, its friction begins to increase. It increases with the soil, of course, because the surface area of the pile is increasing as I go deeper until reaches a certain number below. And so you will find the total skin friction, which is the skin friction of the two components, as you see here. But at the end, there are some results in total skin friction reached 602. Then the factor of safety shall be considered. Therefore, eventually, the allowable skin friction, considering the factor of safety of 2 or 3, i.e. dividing the total skin friction by, notice here, I divided the number by 2, i.e. the factor of safety is 2. The important thing is to take the factor of safety. This is its allowable skin friction, which is for its actual factor of safety. In all these values, you will find the half of this value. Then you can add the point resistance. After considering its corresponding factor of safety, which equals 3 as shown, and so on. And at the end, the table tells you to keep in mind that you now have the allowable point resistance, and so on. Okay, the result of friction and the result of safety. This is a sum of the two components together, but remember one tricky thing. This is the only trick I want to focus on in this video, which is that it does not mean that the longer the pile, you have the max capacity you have with no limit. For example, if you reach the maximum capacity more than 3000 without factor of safety, so the allowable pile capacity of 1140 or 1156. Unfortunately, the actual pile capacity that you have to consider is not this value. What? Because the capacity shall not exceed the pile capacity as a column. Of course, this is a number that needs to be checked whether exceeds the column capacity or not? How? You will find that I am giving you a red marked cells exceeds the column capacity. That is, the pile will collapse as a column, not as a pile. What does this mean? We focus on the note number 6. The note number 6 tells me that the maximum pile capacity shall be limited based on maximum allowable stress of concrete using the following. Formula of column capacity. Yes, this tells you to be careful. This pile will collapse at one of two possibilities. Based on two different equations, either its capacity will be at one of two different behaviors. Either its maximum capacity will be as a skim fraction plus and bearing components, or its pile capacity will be as a column with axial component only. That is why it can collapse as a column before it collapses as a pile. It should be noted that the word collapse for pile shall be clarified in terms of pile capacity. A collapse pile means that it has a settlement more than what it is designed for. The word collapse pile, I just want to clarify it. A collapse under a skim fraction means that the fraction between it and the surrounding soil has no use. It does not mean that it will break. No, it means that the fraction will not be as it should be with the soil. And this is what happens in our pile load tests. We say that this pile has collapsed, not that it has broken. Collapse means that its fraction with the soil will not be as it should be, and therefore it will not give you the resistance that you see in the table. It has lost this resistance, or lost a large part of it. What is a collapse as a column? It is the equation that I take the concrete area of the pile multiplied by FCO, which we said above, which is 9 megapascals, which is 0.25 of FC prime equals 35 megapascals. And therefore it becomes a column. If you multiply 1.2 squared by 4, which is the area of the skim fraction, it will give you a number which is about 1116. I will not calculate it exactly, but it is in the range of 1100. And therefore I am now between 970 to, so I am here. The real collapse as a column is here. So any increase in the collapse of the pile as a result of the skim fraction has no use. Important trick of the natural ground level. So do this. Well, you made your pile 25 meters, but a fraction of the basement. For example, your basement was 9 meters deep, for example. So how much is your top of pile? Your top of pile is 9 meters, which is from the foundation level. Okay, multiply 25 by 9 plus 25. How much do you get? You get 34. So 34 is here. So how much should be the base of the pile? It should be 1410. Wait, how 1410? This pile was a column collapsing on a 1000 something, so I'm sorry. I will not use this value. I will use this value. Your value as a column. Okay, another example. Suppose your pile was 10 meters deep, for example, and Badrown was 9 meters deep. So 9 plus 10 meters, the length of the pile is 10 meters. So it goes down to 19. So 19 meters here. I can walk horizontally and enter here. Yes. How much is your value? It's okay for me. Why? Because I have less than your height as a column. I work with me. Okay. And so on. But of course, at that time, you will have a kind of value engineering on yourself. It is not logical to use a value of 120 to get a load like this. So at that time, you go to the table before it, which is an 80 centimeter table. For example, your value is 80 centimeters or 90 centimeters.
Thank you for participating in this session. Should you have any questions or feedback, please feel free to reach out to me via my Facebook page, LinkedIn profile, or by leaving a comment below this video on my YouTube channel. Best regards.